According to the National Electrical Code or NEC, a ground fault circuit interrupter or GFCI is required for each motor and starter combination in the described situation. Article 250.137 requires ground fault circuit interrupter protection for personnel in wet locations. Since golf courses often have areas that can become wet, this requirement applies. Article 430.52 A1 states that ground fault circuit interrupter protection is required for motors over 1 horsepower installed in other than dwelling units. There is an exception. Ground fault circuit interrupter protection is not required if the motor is supplied through a ground fault protection system that complies with Article 230.95. In this particular case, ground fault circuit interrupter protection is required for several reasons. Firstly, the fans are located outdoors and may be exposed to wet conditions. Secondly, the motors are over 1 horsepower. Thirdly, the starters are not located in dwelling units. Fourthly, there is no evidence of a ground fault protection system compliant with Article 230.95 being installed. To implement this, install a ground fault circuit interrupter circuit breaker or outlet in the circuit supplying each rotor and starter combination. The ground fault circuit interrupter devices should be tested regularly to ensure proper operation. The ground fault circuit interrupter requirement is intended to provide additional protection against electrical shock hazards. It is important to comply with all applicable electrical codes and standards to ensure the safety of the installation and users. Consider consulting with a qualified electrician for guidance and assistance. Article 250 provides requirements for grounding and bonding electrical systems to ensure safety. Section 250.130 specifically addresses methods for equipment grounding and bonding. Subsection 7, as previously mentioned, pertains to ground fault circuit interrupter protection for personnel in specific locations. This article is crucial for understanding when and where ground fault circuit interrupters are necessary to protect individuals from electrical shock hazards, especially in damp or wet environments. Article 430 covers motors, motor circuits, and controllers. Section 430.52 details the overcurrent protection requirements for motor branch circuits. Subsection A1 discusses the use of ground fault circuit interrupters for motor protection. This section is essential for determining the appropriate type and size of overcurrent protection devices needed to safeguard motors from damage due to overloads or short circuits, including the use of ground fault circuit interrupters in certain applications. Article 230 deals with services, which include the conductors and equipment used to deliver electricity from the utility company to the building or structure. Section 230.95 specifically addresses ground fault protection for services. This section outlines the requirements for installing ground fault protection devices on service equipment to protect against ground faults that could cause damage or create safety hazards. The exception mentioned earlier references this article, indicating that if a ground fault protection system compliant with Article 230.95 is in place, individual ground fault circuit interrupter protection may not be required for each motor. Ground fault circuit interrupters work by monitoring the current flowing through a circuit. If there is an imbalance between the outgoing and returning current, which indicates a leakage of current to ground, the ground fault circuit interrupter quickly interrupts the circuit to prevent electrical shock. Ground fault circuit interrupters are designed to detect even small amounts of current leakage, typically in the range of 4 to 6 milliamps, and treat the circuit within milliseconds. This rapid response time is crucial for preventing serious injury or death from electrical shock. There are two main types of ground fault circuit interrupters. Firstly, circuit breaker ground fault circuit interrupters, which are installed in the electrical panel and protect the entire circuit. Secondly, receptacle ground fault circuit interrupters, which are installed in place of a standard electrical outlet and protect only the devices plugged into that outlet. In the context of a golf course fan installation, a circuit breaker ground fault circuit interrupter would likely be the more practical solution, as it would protect the entire circuit supplying the motor and starter combination. Regular testing of ground fault circuit interrupters is essential to ensure they are functioning properly. Most ground fault circuit interrupters have a test button that simulates a ground fault condition. Pressing this button should cause the ground fault circuit interrupter to trip, indicating that it is working correctly. It is recommended to test ground fault circuit interrupters at least once a month. When installing ground fault circuit interrupters, it is important to follow the manufacturer's instructions and all applicable electrical codes. Ground fault circuit interrupters should be installed by a qualified electrician to ensure proper wiring and operation. Incorrect installation can render the ground fault circuit interrupter ineffective and create a safety hazard. In addition to ground fault circuit interrupters, other safety measures should be taken to protect against electrical hazards on the golf course. These may include proper grounding of all electrical equipment, using weatherproof enclosures for electrical components, and providing adequate signage to warn of potential electrical hazards. Regular inspections of the electrical system should be conducted to identify and correct any potential problems. Employees who work with or near electrical equipment should be trained on safe work practices and the proper use of personal protective equipment. The National Electrical Code or NEC is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. Compliance with the National Electrical Code or NEC is essential for ensuring the safety of electrical systems. Local jurisdictions may have additional electrical codes and regulations that must be followed. It is important to check with the local authority having jurisdiction to determine the specific requirements for electrical installations in a particular area. Ground fault circuit interrupters are an important safety device that can help to prevent electrical shock injuries and fatalities. They are required in many locations, including wet locations, construction sites, and healthcare facilities. By understanding the requirements for ground fault circuit interrupters and following safe electrical practices, it is possible to create a safer environment for everyone. In this specific scenario of the golf course fan installation, the presence of water in the outdoor location necessitate the use of ground fault circuit interrupters. This requirement is in place to protect golfers, maintenance personnel, and anyone else who may come into contact with the electrical equipment. The fans are permanently mounted on 10-foot poles. The starters are located at the bottom of the pole. The electrical inspector is requiring ground fault circuit interrupter protection for all of the motors and starters. The installation involves 144 fans. The fans are 3-phase 480 volts. This configuration does not negate the ground fault circuit interrupter requirements. The height of the poles and the location of the starters do not change the fact that the equipment is located in a wet environment and is accessible to the public. The large number of fans involved in the installation emphasizes the importance of ensuring that all electrical work is performed correctly and in accordance with applicable codes and standards. A mistake could be costly, as it could affect a large number of fans. It could also create a significant safety hazard. Ground fault circuit interrupter protection is especially important in 3-phase systems, as ground faults can be more difficult to detect than in single-phase systems. In a 3-phase system, a ground fault can cause unbalanced currents to flow, which can damage equipment and create a safety hazard. Ground fault circuit interrupters are designed to detect these unbalanced currents and trip the circuit quickly. In addition to complying with the National Electrical Code or NEC, it is also important to follow any applicable industry standards or best practices. For example, the Institute of Electrical and Electronics Engineers or IE publishes standards for electrical safety in industrial and commercial facilities. These standards can provide additional guidance on how to design and install electrical systems that are safe and reliable. The use of ground fault circuit interrupters is just one aspect of a comprehensive electrical safety program. Other important elements of an electrical safety program include employee training, hazard assessments, lockout and tagout procedures, and regular inspections of electrical equipment. By implementing a comprehensive electrical safety program, it is possible to significantly reduce the risk of electrical accidents and injuries. When selecting ground fault circuit interrupters for the golf course fan installation, it is important to choose devices that are specifically designed for motor protection. Motor-rated ground fault circuit interrupters are designed to withstand the high inrush currents that occur when motors are started. They are also more resistant to nuisance tripping caused by motor starting transients. It is also important to select ground fault circuit interrupters with the appropriate voltage and current ratings for the motor circuits. The ground fault circuit interrupters should be rated for at least 480 volts and the full load current of the motors. The wiring leading to the motor must be appropriately sized for the amperage draw of the motor. Consulting with a qualified electrician is essential to ensure that the correct ground fault circuit interrupters are selected and installed. In addition to providing ground fault circuit interrupter protection, it is also important to provide overcurrent protection for the motor circuits. Overcurrent protection devices, such as fuses or circuit breakers, are designed to protect the wiring and equipment from damage due to overloads or short circuits. The overcurrent protection devices should be sized according to the National Electrical Code or NEC requirements for motor circuits. The size of the overcurrent protection device will depend on the full load current of the motor and the type of motor starter used. It is important to coordinate the ground fault circuit interrupter protection with the overcurrent protection to ensure that both types of protection work together to protect the motor circuits. The overcurrent protection should be sized to allow the motor to start without tripping the overcurrent device, while still providing adequate protection against overloads and short circuits. The ground fault circuit interrupter should be sensitive enough to detect ground faults, but not so sensitive that it trips unnecessarily due to normal motor starting transient. Regular maintenance of the electrical system is essential to ensure its continued safe and reliable operation. Maintenance activities should include inspecting the wiring and connections for damage, testing the ground fault circuit interrupters and overcurrent protection devices, and cleaning the electrical equipment to remove dirt and debris. Any damaged or worn electrical component should be replaced promptly. A qualified electrician should perform the maintenance to ensure that the work is done safely and correctly. Proper documentation of the electrical system is also important. The documentation should include wiring diagrams, equipment specifications, and maintenance records. This documentation can be helpful for troubleshooting problems and performing maintenance activities. The documentation should be kept in a safe and accessible location. The information provided in this narration is intended for general guidance only and should not be considered a substitute for professional electrical advice. It is always recommended to consult with a qualified electrician for specific recommendations and assistance with electrical installations. The National Electrical Code or NEC is a complex and constantly evolving document. It is important to stay up to date on the latest changes to the National Electrical Code or NEC to ensure that electrical installations are in compliance with current requirements. The National Fire Protection Association or NFPA offers training and certification programs for electricians and other electrical professionals. These programs can help individuals to stay informed about the latest electrical codes and standards. In addition to the National Electrical Code or NEC, there may be other applicable codes and standards that must be followed. These may include state and local electrical codes, as well as industry standards. It is important to check with the local authority having jurisdiction to determine the specific requirements for electrical installations in a particular area. The golf course fan installation presents a unique set of challenges due to the outdoor location and the potential for exposure to wet conditions. By taking appropriate safety measures such as installing ground fault circuit interrupters and following safe electrical practices, it is possible to create a safe and reliable electrical system for the fans. The goal is to ensure the safety of everyone who may come into contact with the equipment. The National Electrical Code or NEC is updated every 3 years, so it is important to ensure that the electrical installation complies with the latest edition of the National Electrical Code or NEC. The 2023 edition of the National Electrical Code or NEC is the most current edition. It includes several changes that may affect the design and installation of electrical systems. Some of the key changes in the 2023 National Electrical Code or NEC include new requirements for arc flash protection, updated requirements for ground fault circuit interrupters, and revised requirements for surge protection. It is important to review the 2023 National Electrical Code or NEC to understand these changes and how they may affect electrical installations. The National Electrical Code or NEC is available for purchase from the National Fire Protection Association or NFPA website. It is also available for viewing at many public libraries. In addition to the National Electrical Code or NEC, there are many other resources available to help electricians and other electrical professionals stay informed about electrical safety. These resources include trade publications, industry conferences, and online training courses. By taking advantage of these resources, it is possible to stay up to date on the latest electrical codes, standards, and best practices. The golf course fan installation is just one example of the many types of electrical installations that require ground fault circuit interrupter protection. Ground fault circuit interrupters are an essential safety device that can help to prevent electrical shock injuries and fatalities in a wide range of applications. By understanding the requirements for ground fault circuit interrupters and following safe electrical practices, it is possible to create a safer environment for everyone.